Hi, I am Gautam Srinivas, Application Engineer for Simulation Products at Aegis Computers India Private Limited. In this video, we are going to validate the Segway through our SOLIDWORKS simulation. Okay, what is Segway? Let's see this through a video. Yeah, here you can see Segway is a personal vehicle, an electrical personal vehicle. This is used to transport us from wherever we like to go, and you can see this is traversed in on-road and in an off-road conditions too. So what the complexity in the Segway? Yeah, it has more complexity, like we need to locate our CG at a correct position, otherwise it will be twist, and it need to be more efficient because it's an electrical vehicle. So we have a lot of challenges. So let's see why validation is required for an Segway. So whether my product will withstand the real world operation conditions, because we can't able to predict how this component or a Segway is going to behave in a real world, because it need to be balanced both off-road and on-road conditions, and it need to be energy efficient because it's an electrical vehicle. By a short span of charge, it need to be transport to a large kilometers. So it need to be more energy efficient. So it need to be a more design optimized model. And other important thing is how long my product will sustain. Yeah, we need to predict that. And whether we need to, more important thing is we need to balance the CG. Yeah, let's have a look how we can do this all the things through SOLIDWORKS simulation. SOLIDWORKS simulation is an add-on product to a 3D model, SOLIDWORKS 3D CAD model. Yeah, it comes as an add-on product in this 3D environment. Here I have an assemble of a Segway with a platform which has 10 small restrictions over it. So I had created the virtual world scenario in the 3D model. So by this I'm going to analyze my Segway. Let's start up with an kinematic analysis, which is known as motion simulation. Motion simulation, I go into an add-on and then I enable the SOLIDWORKS motion will be get activated as a new tab in the existing assemble or in part design. Yeah, here you can see the same tree structure what we had seen in the existing assemble. The same trees gets transferred to motion analysis, and the main important thing is all the 3D geometry and the material what we had applied in the 3D geometry need to be get transferred. So the mass property of the model will be get transferred. All the things will be done automatically. So what will we have control? We have control in the motion analysis. Here you can see a time frame line. So based on dynamic condition, we can able to set up how long we need this analysis need to be done, and we can able to create various controls like motor for an rotating conditions. So what type of motor we need? It's a rotary motor or a linear motor. In this case, we need a rotary motor, so my wheels need to be get rotated, and we can place where the motor need to be centered and what type of motor I need, whether it need to be rotate constantly at a constant speed, or it need to be get oscillator, or a segment based motor, like for a particular time frame it need to be made in a certain RPM and it need to be reduced to RPM, like that. Based on segment conditions we can do. So like this we have lot of types of motors. Yeah, I had applied a rotary motor over this wheel which need to be rotated at a constant speed, and the main thing, we need a contact or a friction factor need to be maintained between the wheel and the floor. That friction factor can be specified using this contact conditions. So in the contact conditions we can specify whether it's a solid body contact or a curved surfaces contact. In this we can do with the two type, whether we know, if we know the friction factor between the surfaces, we can manually provide in this friction value, or else we can customize them manually. Like I know the friction value, so we can able to specify here whether it's a slippery surface or a sticky surface. If you don't know the friction value, we can go with the material type. So between various type of material type, like if it is a between the rubber dry and the surface is need to be in a steel or an rubber surface, you can specify that. So the friction will be provided automatically. So we can go with two types. And whether if we have any spring conditions, or we need to find out what spring will suit for the model, all the things we can able to give. Whether if it has an force over it, we can able to provide that. I had provided two contacts on this between the each wheel to the surface, and we can able to specify the gravity. So by this gravity option, what we can do is we can able to know how the orientation of model is in the real world. So I had specified the gravity throughout y-axis, a negative y-axis. So the software will know how the model is get oriented and how the mass of the model need to be get activated towards the Earth's surface. And I had set this to a specific time, and when we calculate, you can see how exactly the software will predict our model will be work in the real world scenario. So we can able to view virtually. So you can see there is some vibrations or a shake in the initial conditions, and when it moves, how the model is get changed with the CG conditions. So here I need to get the results as in two factors, like how much torque is required to drive this motor. So for this we have options called results and plot. By this we can choose what type of results we required, whether it need to be displacement or velocity or acceleration, or it need to be a force, or I need to find out the energy, moment and power. So here I need to find the torque. So I will go with the force, and here what type of force we require, whether it's a motor force, motor torque, reaction force. I require the motor torque, and what axis it need to be. I need the magnitude. So after that we can specify the motor. For what motor we need the motor torque. Okay, just when you pick the OK, it will be develop a graphical representation of the torque developed through the entire time frame of analysis. So we can specify at what time frame the peak torque is achieved and what is the average obtained torque. This one also we can able to see virtually, and we can compare with the plot and the virtual generated animations. And I need to find out the CG transfer between CG movement in the entire analysis. For this I had already created and preset plot. So by this you can see how the CGs get transferred at each cases. So after the restrictions you can see the CG is changed drastically. So we can able to redesign, or we can able to change the concepts. So after that I need a fully animated video that able to export as an animated file based on various type of format and what resolutions we required, and we can save it as an animated images. So we can use it for an communication purpose or a presentation purpose. Okay, I had seen these kinematic conditions, like how much torque is required and whether the CG is maintained in my model or not. And now I need to validate whether this platform, the base platform, is withstand my given load or not. So let's do an FE analysis. It's a finite element analysis to check whether this is withstand the given load and where is the weak regions, and whether I need to go for a redesign or it is over design or not. Okay, we had taken the 3D model of the platform. So the simulation strength analysis is also an add-on product to our existing 3D CAD. If you pick the add-on, it will generate a new tab, a new column or a control panel for this entire simulation. It will be plugged into our 3D CAD platform. So for the sake of analysis purpose, I need to simplify this model. So I need to remove the unneeded regions. So I require only this platform. So for this, in the 3D model, we have a advanced technology called configurations. So through this, we can able to make multiple design approaches in the same part file itself. So I had simplified my model. So I had taken what are the required geometry alone, and we can go with an FE analysis. So this is FE analysis, which is we can use it as a tab within our 3D model. So anytime we can switch between the analysis and the modeling window. So you can see the same tree structures like what we had seen in the motion analysis, and it also carries the metal property of the 3D file what we had designed. So what metal we had provided in the part file, it also get transferred through the simulation also. So within the 5 simple steps, we can able to set up the entire simulation window. So first thing is I had provided the material which is automatically get transferred, or else I need to change the material, that is possible too. So by right clicking, we can apply the material. So we can choose what type of material we required, and you can see what is the main property or main mechanical properties required for this analysis. Like we need the mass density, Poisson ratio, and elastic module. So based on the load condition, what are the properties is required also, it will be listed out. We can able to customize the property, or we can able to reuse the standard material also. So the next thing is connections, like how my object is get contact with the other 3D models, that we can able to give with the content set, like whether it is a welded or it is need to be like slided between the 2 parts, we can specify, and how my model is get mounted with the other model through a bolt or a bearing or a spot welder. These all things are virtually generated geometry. We no need to create any 3D model for this connections, like bolt, a real bolt, a 3D model, or a real bearing. That is not at all required. We can able to reuse of this virtual generated connections. So when we pick for a bolt connector, it will ask for what type of bolt is you going to use in this example, and we can specify the edge where it need to be get mounted. So this size and all automatically will get calculated, and we can specify what type of material we are going to use, and we can also give what is the pre-torque or preload we need to apply on this bolt. So based on this, after running the analysis, we can get an results how whether my bolt or connector is safe or not, and how much time is safe, and what are the stresses at on this bolt. Okay, now I need to tell my assemble like how my model is get mounted. So you can see we have various type of mounting conditions like fixed geometry. So all the name like roller and slider, fixed hinge, all the names are very familiar to us. It was not like an FA language at all. So we can able to easily guess how the content is going to be supported. Like if we give the fixed geometry, our model will be fixed at 6 degrees of freedom, like an anchored model. If we pick the fixed hinge, it will be arrest only the axis, it will get rotated 1 degree of freedom will be leave. So based on this, we can have fixed this both surfaces with fixed geometry, which is get mounted with the other part. And the next thing is I need to provide the force. What type of force is going to act over this model? In this platform, a human is going to be stand over this model, so the entire weight of the human will be get transferred through this platform. So for this, I need to provide the force. Additional to that, we have various options like load factors we can able to apply called torque, pressure, gravity. So I need to apply the force. So I had applied a force over this platform, like for a maximum type of loading, I had given 200 kg weight of object is standing over this platform. Okay. The next thing, the most important thing is we need to split this model into a small element, since it is an infinite element approach, analysis approach. So for this, we have 2 types of analysis we can do. Either we can go with an auto setting, or we can go with an manually given method. So first it shows for an auto settings, like whether it will be core or fine or a software suggested element size. So whether we need to go for a manual approach, we can enable this one as parameters, and we can manually give what's the size of element need to be carried out towards this model. So I had already meshed this model, so I will show you a preview of how I had meshed this one. So it will divide our model into a small element, and will recreate a 3D geometry based on this elements. Okay. So the next thing is we need to run the study. Okay. So just by when enable this run this study, we can get this for 3 plots automatically. So first thing is we need to know how much stress is developed in my model. Okay, let's see. It will be sourced in a color code format. So based on this color chart, we can view that the 39 megapascal of stress is built on this model. So I need to know at what portion this maximum stresses get developed. So when I pick maximum annotation, the software will source the maximum stresses obtained at this base area of this model. Okay, so it's developed 39 megapascal, and I need to find out how my model is get deformed or displaced when I apply the load. For this, we can go with the displacement plot. So here you can able to view the maximum displacement happen is 3.5 mm. So I need to know how this part is get displaced. So for this, we can able to animate and view. Before animating, I need to scale up this value, like because 3.5 mm will be not taken to override. So we can go for a deformation shape with an auto scale, like 35 times it will be enlarge our model and view to us. So when we animate, we can able to easily predict how my model will be get displaced when apply this much of load over this platform. So based on this, we can able to virtually view at what portions what type of prolongation is happens. So to reduce this, we can able to provide the supports, but here my factor is it's for 3.5, which is within my tolerance limit. So finally, I need to view how much time my model is safe. So here, by using the factor of safety plot, we can see our factor of safety of this model is 4.3 times. So 4.3 times this object is safe. So in my idea, the 2 times safe is enough for my model. So this is 4.3 times, which is twice it's safe. So I need to reduce the mass of the model to increase the performance of my Segway. So let me do a mass property. I need to find out the mass property of this model, so I can able to have a look how much kg it is. It is 6.3 kg, this platform. So I need to know where I can do my design changes. So for design changes, we need to go or remove the material at a less stress acting area. For this, software will give us the suggestions by using this isolate clipping options. So in this isolate clipping options, we can specify up to what level you need to view the stress factors. So I had provided like the minimum area, like minimum 10 megapascal or a minimum 5 megapascal of load is acting throughout this areas. So wherever we can able to remove the material, it is safe. It will be within the safe. Like the blue regions or the areas which the 5 megapascal is acting. So I plan to remove the mass of the model at the center region. Okay, just we can go with an design change. So let us suppress this extrude, and also I suggest to reduce the thickness of this model also. So I had created another configuration in which I had reduced the mass of this model. So what are the factors I had reduced is I had created a cutout on this area, and also I had changed that I had reduced the thickness of this geometry. So I need to set up another analysis for this new configurations. So it also has it will spend some time. So to avoid this, we have a easy options called, we can able to copy the study and we can say at what study it need to be get copied. So by this options, all the parameters what we had set it in the previous study, it will automatically get transferred to the new study. So it will easy for us to get analysis, and it will reduce our time in setting the setting up all the properties like load, mesh settings and fixes once again. So by copying this, when we rerun this analysis, it will source the stress stresses for this new configuration or a new model, mass reduced model. So now my stress developed is maximum 64 megapascal, and the displacement achieved is 6 mm, which is also within my limit. So let's see what's the factor of safety. The factor of safety is 2.3. So my allowable factor of safety is 2. So now it is much quite enough for me. So this 2.3 times safe is enough, which is within my limit. So let's see how much mass we had reduced in this new design. Just we can go for evaluate and then mass property. You can see 4.2 kg of mass is there in this model. So totally 2 kg of weight we had reduced in a single unit. So I had reduced my mass, increased the performance of my Segway. So we had reduced the mass, but we need to see how long my product will sustain with this new design concept. For this, we have a new study called fatigue analysis. So based on this fatigue analysis, we can see how much my model will be withstand based on repetitive load conditions. We can validate this based on constant amplitude, or we can able to go with a variable amplitude. What's the difference between the both? Constant amplitude is a given load like 200 kg will be constantly acting at a given time frame. Or if you go for a variable amplitude, the load factor will be scaled up or scaled down based on the time frame. So I had go with the constant amplitude. So I had created a fatigue study. In this also you can see the same state structures, and we need to add the event as an input. In this event, we can import the existing FEA studies. So I had imported this design change analysis in this fatigue analysis, and based on this we can able to calculate how long my product will be withstand. You can see the minimum the cycles it will withstand is 34,244 cycles. At what area this minimum cycle is occurred is here, at the bottom of this platform at an fillet. So the first fatigue crack or a depreciation will be start at this radius. So we can see what is the minimum cycle we can achieve with this design changes. So let's do how long this product will be sustained. So I had done a small warranty calculation. By fatigue we can able to predict how long my product will get sustained. So we can able to suggest the warranty time of our model. So in this study we had obtained a 34,244 cycles. So each day, let us assume for each day we have the 20 time scenario of this load cases acting. So if we divide this 34,244 with 20 times, so our model will be withstand for 1,712 days, which when we converted to an year, 365 days per year, our product will be withstand around 4 years 6 months time. So by this you can able to calculate the warranty time of how many days or how many years the model will be get sustained. So through this analysis, by using motion and FEA strength analysis and the fatigue calculations, we can able to optimize our design to an best quality design without compromising any stress factors or without compromising with the strength of the model. So this platform, entire validation platform comes along with the Sawdust 3D CAD platform itself. So we no need to transfer our 3D data to any other format and we lose our geometries. So by this we can able to predict the exact warranty time of the model, and we can able to go with a better energy efficient design. By we can able to virtually view where we can reduce the mass or where we need to add the support for this model. And in this Segway we need to maintain the CG of the model. That also we can able to have a clear view how the CGs get transferred in the entire real world scenario. Like we had animated through an restrictions, so we can able to virtually view how the CGs get transferred or the CGs within the limit. And by this, using all these validation tools, we can able to virtually view how my product is going to behave in the real world. And we can able to, by concluding with all of this, we can able to provide a best design with less mass with the high quality of design. So thank you for watching this video. If you have any inquiries, kindly contact to this given informations like email or www.agsindia.com, or if you need to directly contact us, kindly go with this contact numbers 944542470 and 0404424803370. Thank you.